So both 4.3 and 4.4 are kind of small, so we lumped them together. So here we have two square roots inside a fraction. And one of the rules of simplifying square roots is don't leave a square root in the denominator. Okay, just like if you have a fraction that's 10 over 20, the simplification rules state that you need to remove the common factors from the numerator and the denominator, so we divide out a 5 or a 10 and we get 1/2. There are lots of rules for simplifying square roots. One of them is don't leave a square root in the denominator. So how do we remove a square root from the denominator? It's simple. We just we multiply the bottom by itself. Okay? But that's going to change the value of the fraction. So I multiply the top by itself as well. What is this number? Just 1. What happens when you multiply by 1? You get the number you started with. So we're multiplying by 1. It's a special one. It's root 6 over root 6. And that's going to turn the bottom into a non-square root number. We call this rationalizing the denominator. And then the top is going to be a little bit messier. But what is the square root of 6 times the square root of 6? It's the square root of 36. What is the square root of 36? It's just 6. So anytime you multiply a square root by itself, the answer is just whatever's on the inside. Okay. What about the top? Well, the top becomes, I don't even know what that is. So the top becomes 66 times 6, which is 396. But I don't really care what it is. So that becomes the square root of 396. Right? But I'm just going to factor that. What goes into 396? Well, where did 396 come from? 6 times 66. So I know that this is 6 times 66, 2 and 3, 11 and 6, 2 and 3, and then we can cross off everything that factored. Does anything come out? Well, we have a set of 2's and a set of 3's. So what do we write on the outside? 6. And then what did not come out? The 11 didn't come out over 6. Can we simplify further? Yes. The 6's cancel, and the answer is the square root of 11. Now this time it definitely looks more simplified than it was before. Sometimes when you do this, you end up with a number that looks more complicated than the one you started with, but we always rationalize the denominator no matter what. That guarantees that everybody gets the same sort of number. And a lot of the time, it will simplify into something that looks less complicated than the original, but that's not always going to be the case. What if I had 6 root 15 over 9? Could I simplify that further? Well, what do 6 and 9 have in common? A 3. So that would be 2 root 15 over 3. Can I simplify that further? Well, do 15 and 3 have anything in common? They do, but I'm not allowed to simplify that. Okay? 15 is 3 times 5. But those are not really 3's and 5's. They're the square root of 3 and the square root of 5. And the square root of 3 cannot simplify a 3. So when you're simplifying radicals, outside can cancel outside and inside can cancel inside, but not the other way around. Okay, let's do another one. Here we want to rationalize the denominator. So I times the bottom by the square root of 63 and the top by the square root of 63. The bottom just becomes 63, and the top becomes the square root of 7 times 63. So let's simplify that. 7 and 63, 7 and 9. What can I bring out? Bring out a set of 2's and the 7's. So what do we write on the outside? Well, it would be 7 times 2, so 14. What's left on the inside? Well, this doesn't count, and this doesn't count. Did anything not get circled? No. So everything came out. So 14 over 63. Do 14 and 63 have any common factors? 7. So we pull out a 7 and we get 2 over 9. That is the simplified version. Do you want to see another one of those? Yeah? Okay. Multiply by root 2. And we get the square root of 100 over 2. What is the square root of 100? Just 10. 10 over 2 is the number 5. Okay, next one. Same idea here. Multiply by the square root of 2 over the square root of 2. The bottom just becomes 2, and the top becomes the square root of 14. What goes into 14? 2 and 7. Do we have any pairs? So we have 14 is 2 and 7. Can I circle anything? No. So the answer is just root 14 over 2. All right. Now for these next problems, special right triangles. So here we have two different triangles, and it wants us to find the missing side lengths. Are those triangles similar? Do they have the same shape, just different size? No. So how am I going to figure out a missing side length if I don't know a similar triangle? And the answer is there are two special right triangles. We call them special right triangles. And one of them looks like this. It has a 60 and a 30, and the side lengths are 1, 2, and the square root of 3. And then the other one is a 45, 45, 90, and its side lengths are 1, 1, and the square root of 2. So let's lock this. I'll leave these two triangles up on the board, but there will probably be a question on the ACT when you take it that deals with one or both of these triangles. Okay, So you sort of are supposed to memorize them, but I'll leave them up on the board for today. Any triangle that has the same angles as either of these is going to be similar. So this triangle matches up with that triangle. So how do we find A? 3 divided by 1 is equal to A divided by root 3. Now we cross multiply. A equals 3 root 3. And then it wants the answer to the nearest tenth, so you just plug that into your calculator. Okay. For the next one, 8 lines up with the square root of 2. So 8 over the square root of 2 is equal to C over 1. So we cross multiply. 8 equals C root 2. We divide by the square root of 2. And we get 8 over root 2 equals C. Now, I'm not allowed to leave a square root in the bottom. So technically, I should rationalize the denominator, but how does it want me to give the answer? In a decimal, in tenths. So I can just plug this into my calculator, and it will give me the answer I'm looking for. What if it says give me the exact answer? That means the one with the square root in it. Then we have to rationalize. So to rationalize this, we would times by root 2, and I get 8 root 2 over 2. Can this 2 cancel either of those 2's? Only one of them. Which one will it cancel? The 8. So 4 root 2 is the answer. Okay, let's do another one. Okay, same basic idea here. We're going to use the special right triangles. 7 matches up with root 2. So 7 over root 2. And C matches up with 1. C over 1. Cross multiply. C root 2 is equal to 7. Divide by root 2. And this one wants simplified radical form. So I need to get the root 2 out of the denominator, times by root 2 over root 2. We get 7 root 2 over 2. And this is one of those cases where the answer looks more complicated than the original. So the original was 7 over root 2, and the simplified version is 7 root 2 over 2. But we still want to use this version. That is considered simplified. So every once in a while, you'll simplify, you'll rationalize the denominator, and you end up with a number that looks more complicated than the one you started with. But that's okay. All right, for the next one, 5 matches up with 1. And A matches up with root 3. Cross multiply. 5 root 3 equals A. And I'm done. All right. Let me erase this.